Millions of worn-out tires, stacked into endless mountains of rubber. A global waste problem, growing every single day. Old truck tires, passenger cars, industrial vehicles, all discarded, all piling up. But inside this massive recycling plant, these tires won't be buried. They won't be burned. Instead, they'll be transformed into high-performance rubber asphalt, used to build stronger, quieter roads. And it all begins right here. Every day, trucks arrive loaded with used tires from highways, garages, and construction fleets. But not every tire is ready for recycling. Some are contaminated, filled with dirt, oil, or debris. Others are too damaged to process efficiently. So before anything begins, each tire is inspected and sorted. Large industrial tires are separated from smaller ones. Different rubber compositions are grouped together because consistency matters. In a process like this, even small variations can affect the final product. Now the real breakdown begins. Whole tires are fed into powerful cutting machines, where rotating blades slice them into large chunks. Then, into the shredder, a machine designed to destroy rubber at scale. Massive rotating shafts grab the tire pieces, pulling them apart with brutal force. Rubber tears open, steel wires snap and twist. In seconds, a solid tire becomes fragmented material, no longer recognizable, no longer waste. Now, it's raw input. Tires aren't just rubber. Hidden inside every tire are layers of steel and synthetic fibers, and they must be removed. Powerful magnets pull steel fragments out of the mix, separating them instantly. At the same time, air systems extract lightweight fibers. What remains is mostly rubber, clean, processed, ready for refinement. Nothing is wasted. Even the extracted steel will be recycled again. Now the rubber moves deeper into the system, through a second stage of grinding. Here the material is crushed even further, into smaller chips. The size becomes more controlled, more uniform, because for asphalt production, precision matters. Too large, the mix becomes unstable. Too small, performance is lost. Everything must be just right. some advanced plants, the process goes even further. The rubber is exposed to extremely low temperatures using liquid nitrogen. At these temperatures, rubber becomes brittle, almost like glass. Then it's shattered, breaking into fine particles with incredible precision. This method creates ultra-clean rubber powder, ideal for high-performance asphalt blends. Extreme cold unlocks a new level of control. Now the material is sorted again, not by type, but by size. Vibrating screens separate the rubber particles into different grades: fine powder, medium granules, larger chips. Each size serves a different purpose. Only specific grades will move forward into asphalt production, because the final road depends on this exact composition. Transformation. The rubber meets asphalt. Bitumen is heated to extreme temperatures, turning into a thick, flowing liquid. Then, rubber particles are added. Slowly, carefully, the mixture begins to react. Rubber absorbs the bitumen, expanding, bonding, transforming the structure. The result is rubberized asphalt, more flexible, more durable, more resistant to cracking. This is where waste becomes innovation, where old tires become the future of roads. Now the material leaves the plant and heads to the real world. Paving machines spread the hot rubber asphalt across highways and urban roads. Heavy rollers compress the surface, creating a smooth, dense layer. The result, a road that lasts longer, handles stress better, and even reduces noise from traffic. Most drivers will never notice, but every mile tells the story of recycled tires. Before it's approved, the material must be tested. Engineers analyze elasticity, durability, and resistance to heat and pressure. Samples are stretched, compressed, and stressed because roads face extreme conditions. Heavy loads, temperature changes, constant friction, and failure is not an option. Only the highest quality mix makes it to the road. Once approved, the rubber asphalt is transported to construction sites across the region. Timing is critical. The material must stay hot and workable. Crews move fast, laying, spreading, compacting. Within hours, a new road takes shape, built not from fresh resources, but from recycled waste.
Hold it right there. Keep it coming. Watch the edge. All right, next truck's here.
Once rolled across highways is now the highway itself. Millions of discarded tires reborn into something stronger, smarter, more sustainable. And tomorrow, more tires will arrive, more rubber will be processed, more roads will be built. Because in this system, nothing truly disappears. It just becomes something new.